So we're going to start with coroutines. For those of you who don't know, coroutines are the new way of how we handle sync calls, API calls, long tasks over Kotlin. Okay. Our outline will go as follows. Why are we using Kotlin instead of Java? Introduction to coroutines. I'm going to give you a working example with the code and everything, and then I'm going to recommend the best practices that we are going to use, that we should be using with coroutines. Like coroutines alone is good, but they are not enough. So when we say Kotlin versus Java, why should we use Kotlin instead of Java? Okay, who do you think has null checks? It is Kotlin. Okay, well, what I mean by null checks is that when I talk about Java, if anyone knows how to initialize a variable in Java, let's say I initialize string, okay, and then I try to access x.length, for example, it will return a null pointer exception. However, in Kotlin, if I initialize var x quotation question mark equals to null, and then I try x.length, here give me an error. It will not build, because I should be sure that that I have to two marks, which means that I am 100% sure that this variable is not null, or I should mark. In that way, Kotlin will check if the variable is null or not before accessing it. This will prevent a lot of null pointer exceptions. Extension functions. They are for by extension function is that there are certain functions that I could use with the Kotlin rather than having another class extended in Java to be able to use them. Exception check. With Java, I can have multi-threading, and there are, well, also with Kotlin, but with Java, I will get a warning to add an exception, whereas with Kotlin, I do not get this option. So this point goes to Java. In addition to that, static methods. Static methods and variable. We do have a way of showing static variables and methods with Kotlin, but in that we have to create a companion object and have everything else inside it. Whereas in Java, it is so much easier. Static string x, and this variable will be static. Okay, so those are the main differences. Of course, there are way more differences with Kotlin versus Java. However, the main differences with respect to someone who has tried both, Kotlin is easier and it is more lightweight. We have less line of code while writing. This is a huge advantage. Google is recommending the use of Kotlin over Java. In addition to that, we have the smart. This goes with the is underscore check, and the point goes to Kotlin. What about coroutines? Coroutines are a new style of concurrency developed way back in time. It has been around in 1967. Many languages have implemented it: JavaScript, Go, Ruby, and so many other languages. Now Kotlin has implemented the coroutines, and they are used for long-running tasks. In addition to that, they solve the problem of providing main safety, because I can call the suspend function on the main thread without having to worry about main thread exception, unlike Java. This will also lead to a more structured code, in a very cleaner way, and it will be definitely more lightweight. How about we dive into the code right now? First of all, we are going to add the libraries. Those are the libraries. The three first libraries are for Coroutines, and the second two libraries are for retrofit. If you notice, we have the retrofit itself and the converter JSON, because we are going to use the JSON syntax of a dummy API, and it will automatically be converted into an object. Okay, so those are the libraries we are going to use. I'm going to show you how the code will look like in the screen over here. Give me a minute. Okay, so here they are. Kotlin alone is not enough coroutine alone is not enough to call an API, so that's why we use a networking library. We can use RX Java, we can use Volley, but I prefer using retrofit. After that, we are going to add the coroutine scope and its overriding functions. And I will show you how they will look everything in the at the code or the level of the Android Studio. The coroutine scope is used, it handles on its own of the coroutine. The life cycle of the coroutine is handled through the coroutine scope. We implement this interface and its overriding functions. If you notice over here, I have a dispatchers.main, which means I can have access to the main function and the job to handle the coroutine itself. Next, we are going to add a progress bar in the XML to show the loading and reference it from the activity. I'm going to show you how the code looks like over here. Okay, so this is the main of the coroutine scope. Okay, let's try this. This is the job. These are the two implementing functions. If we go to the activity.xml, okay, here is our progress bar. Okay, it is found inside the constraints layout. This is the ServiceFactory class. So this class, if you notice over here, there is the companion object. This is the companion object that allows me to use this function to create retrofit service as a static without actually having to create the class. Okay, if we notice that the function returns a generic type, a generic type T. This is because I want to use this function to return any type of class. That means if I create any API, I will have its corresponding JSON response in a Kotlin model. Okay, so this is all retrofit over here. We have the coroutine call adapter factory. Okay, this is also implemented in the library. JSON converter factory, as I explained before, it is the part of the library JSON converter retrofit library, which converts the model, the JSON model into a Kotlin model without actually having to do that by hand. Okay. So we are going to use this API over here. Can you see this? So this API, this is a dummy API, of course, and it returns the following: the user ID, title, completed, yeah, true or false. Okay. So if I want to replicate this model at my side, it is going to look something like this. Okay. So this is my data dummy object. It is called, because it's the only responsibility for it, it is called data, and it is found in the primary constructor. This is how we do it in Kotlin. Okay. I don't add any serialization over here because the variables are an exact match to the variables over here. Okay. And let us continue. Okay. This is our dummy interface. So retrofit works by adding an interface. So here we have it. It's a type of get. Okay. I have here .1 because the API ends with a 1. I add the base API for retrofit. This is my base API. So this API will be repeated throughout the whole application. And this is the part that's going to change. Okay. The return type of it is deferred. Deferred is part of coroutine. It will tell me that this is a coroutine task. Response is for retrofit so that I would know if it's completed or is it successful or failed. And dummy object is the object that we created to serialize the JSON. Always remember internal information. If you not really it uses both, so we should add both. If we don't add any of them, the request will actually not go through. As I said, when I add the word span, it's a coroutine function. Inside a normal function. This is a, it could be below, might take a long time. So this is how it's here, adding that my progress bar is visible. You are should I'm adding my risk. If you can see here, I put this response null. Trycatch core does have trycatch to add it. So some when you run trycatch, it will. However, if you are and not looking for is try to add. Okay, so with dispatcher of the input because an thing I think the response equals ServiceFactory dot create retrofit service. See, it's exactly like Java. I am using it in a static way. This is the create retrofit service, the function that was inside the companion object. The class is going to be iDummy API. Okay, the API, the interface API that we created. I will give it the base URL, which is going to be the same. Oh, sorry. Which is going to be the same across the whole application. And then I am calling the function inside the iDummy API. I'm calling .await. Okay, so .await is because I have the getDummy object async. The function as the return type of it is deferred. So .await means it's like .execute. Like right now we are executing the API. So after this finishes, I get the response. So why don't I have response inside the get context dispatchers.io? Simply because I need the pb.visibility. I need to finish the loader, end it, and I cannot access the UI objects main activity unless I am doing it over the main thread. So over here, I only need it to get out of the application, get over the internal information I need, and then come back. Whenever this is done, I should go back to my main thread. And when using my main thread, I am going to access the UI that I have inside my main activity. Okay. So keep visibility view.conf. If response 2 exclamation marks. I checked here that response is not null. Now I am 100% sure that response is not null, so I can put the 2 exclamation marks dot is successful. This is, if I don't put the 2 exclamation marks, Kotlin will not allow me to run the project. Then, if response.body is not null, I got the response. Remember, we have deferred the response dummy object. So deferred is done. We got it from the. Now I'm checking if it is successful or not from the response part of retrofit that I am wrapping the model with. And now I am getting the body. The body, which is the dummy object that we created. If the dummy object is not null, I am here posting a toast of the user ID, which is an integer, and transforming it into a string to show else I am posting an error. The exception, sometimes we have the internet get during mid request. This will cause an exception. Sometimes the server is down 500 bad requests. It might cause an exception or it might come over here. It really depends. Either cases, the PB should also be gone over here, and I also print an error. Up till this point, try catch. Just a minute. Okay. So try catch is for because I am using, I am getting out of the application, I am accessing the internet. So as I said, Kotlin does not have a try catch, does not force us to have a try catch. However, in Java, we are forced to have a try catch. How to know when to put try catch in Kotlin? This comes with experience. But a small hint, whenever you are trying to get out of the application, to anything that's internet related, always have a try catch exception. Okay, if you are trying to read from a file, for example, storage, or from the assets file which is found inside the Android Studio, also have a try catch. You know, okay, we don't need try catch for casting exceptions, because in Kotlin, as I said, we have the is-check, which is the smart cast. Let's continue with context dispatchers over I/O, input output. Okay, I am getting the input over the API as a JSON. Okay, I have the response ServiceFactory dot create retrofit services. This is the function that is used to access statically the function that was found inside the companion object. iDummy API, which is an interface, the interface we created. Okay. I am also giving this function the base URL. Dummy object, async the function inside the iDummy API, which returns, which is the main return type of it is deferred. Because the main return type of this object is deferred, I could call .await, which is something .execute, but it is coroutine related. Okay. Okay, great. So I'm just making sure we don't have any problem with the audio. Okay, now we are at this line. If response is not null, I got the response, which is outside the context. I did not put the response inside the context because I already am the input output, and I do need the PB, which is created in the main activity on the main thread. I do need it, and I could not access it from an input-output thread. Okay, I need to access it on the main thread. So take it as a rule. Whenever you're done with whatever that needs to be handled in the input-output thread, instantly switch to the main thread, because the input-output thread will get skilled, and this way you will save memory for your application. Okay, pp.visibility view.gone. Response, I made sure that response. So right now I can use the 2 exclamation marks. If I do not use the 2 exclamation marks, Kotlin will not allow this application to run, because you have to tell Kotlin that I am 100% sure that this response is not going to be null. I'm checking if it is successful. So number 1, the deferred is in the await over here. I finished with it. If you remember, we have deferred less than greater than response wrapped in another less than the dummy object that we created. So the deferred is done. Now we move on to the response. Response tells me if it is successful or not. Okay, I am checking here. So it is successful. Now I need to move on to the body, which is the dummy object that we created, the JSON object that automatically got it transformed or translated into the dummy object, the Kotlin dummy object. Okay, toast.make, I'm showing a toast in the application. Response body, I'm just showing the user ID, which is an integer to string. Okay, else I'm showing an error. In the exception over here, I'm also dismissing the progress bar, because we don't need the an infinite loader on the screen, and I'm also showing an error. Sometimes exceptions can happen if the internet gets cut off while I'm trying to access the server. Sometimes a 500 bad request can cause an exception. Usually it causes an error over here, but sometimes it does cause an exception. Is everything all right over here? Should we see the code in the application, how it's written? Okay, I'm just trying to check, could mirror my phone. So that I could show you a working example. Unfortunately, I don't know why, but the mirroring is not working. Okay. Excuse me. Okay. Anyways, I'll show you the code in Android Studio while I'll try to fix the mirroring. Yeah. So this is the main activity that we have over here. Don't mind the errors. It's because Gradle did not sync well. Okay. So this is the suspend function. And this is how I launch the function. Okay, launch. It's related to the coroutine scope, and I call the function over here. Let me try to see if I could download this. Meanwhile, does anyone have any question related? No question? Everything is so clear? Anything related to Android in general? Doesn't it have to be just related to coroutines? Okay. Oh, it's gonna be a while. No, I did not expect no one to have any questions. I would have made the session way longer. Try to connect it again. Okay. No, doesn't want to work. Does anyone have a mirroring option that I could download from my phone to the computer? Okay, let's try again here to sync it, and maybe I could launch the emulator. Oh, maybe 3.6. No, what? Let me get my other laptop and I'll show you over the laptop. Just give me a minute. Let's see if the image is going to be clear. Oh, yeah, it is. Okay. Did you guys see the emulator? We're going. This is the progress dialog, and the toast appeared. I did not think that you could see it. So let's try to run it again. I'll try in a way to make it a bit clearer. And if the download finishes early, I could show it to you on a real phone. Okay, and I cannot see it, and it's over here. Okay, the toast is going to appear somewhere over here, and it's going to be in gray, okay? Let's hold this. Okay, I really hope you guys saw that, because I'm tired of... So, this is it. Do you want me to... The download of the mirroring is going to take 3 more minutes, and I don't think we have that much time for that. So I'm just going to settle in with any questions. Does anyone want the code? You could connect with me on LinkedIn and ask me for it. I will be more than happy to send it. If you do need any help concerning Android in general, also feel free to let me know. I just have one more slide to show you. Okay, as I told you, teams alone are very good and a great way of doing long tasks or main thread blocking tasks. However, they are not enough. First, Google introduced something called live data. Live data is it's like an observer that's alive throughout the whole application, but it has additional value that it is life cycle aware. It is made for the Android life cycle. There are other observers, for example, like RX Java. However, they are not enough because, or you could use them, but you need to handle like our live data handles on pause, on resume, on stop, on destroy, on start, on create, everything on its own, which is a huge relief. Dagger or Coin, we need to use dependency injections or singleton classes in other ways so that we don't have so many instances of any classes we're going to create, for example, repositories or anything else. MVVM architecture, model, view model. You actually have anything related to fetching anything from an API call. And the model, we already have the model, we already have the view. What is missing in this is the view model. So actually all the code that you saw concerning the suspend function has to go into something called the view model. And using the live data, it will trigger an event at the level of the view. And if you want to use caching, I highly recommend you. Having used Sugar ORM, RealM, Room is the library to go with because it is also, you can also integrate live data with it. Google created it and it is a huge help if you are going to use the MVVM architecture. MVVM wasn't created by Google. Actually, it was first created by Microsoft and then it was adopted by Google for the Android development. Okay, guys, I guess that's it. Okay, I'm going to put my LinkedIn over here. I don't have it here. Okay, I think you can see it in my profile. Let me see. Yeah, here it is. So this is my LinkedIn account. So if you want anything regarding Android, if you simply just want to just have a question, if you want anything other than that, just simply let me know. And do you have any questions? Any sort of question, career advice? Should you use Java, Kotlin? Should you use Platform, Flutter versus Android Studio? Anything else, I'm happy to answer it before I end this session.